So now I'm back. I actually found out that we were doing those corrections of the coordinate 1 file, but we made a coordinate 2 file. If I hadn't corrected that, then the photometry package would have done photometry on all these catalog stars here. But as you can see, we have a lot of stars in the I catalog. We have less stars in all the other filters, and come to think of it, I actually think that I perhaps set, as you can see here, I try to sort of snoop around a bit. I think I set this to a lower number, but I probably didn't because I haven't changed it since well, in any case, I think I got more stars in this for this cluster here than these 3 here, but perhaps I didn't. In any case, well, I know I did, because I have a lot of them. But yeah, I'm actually not sure what I did. But in any case, you can fiddle a little bit around with obvious. If you change the threshold to a lower number, like 15, for example, or 20 or something like that, you will get more stars, obviously. Alright, but now we have these 2 files here that we need, and then we take a look at the FOT. Because as you can see, we get we could have put in the sky value files if we had that. We don't. We have set up all our values that we need here. I don't want interactive mode. I don't want the radial profiles. I don't want to change with this. You could set verify to know if you just want to run it, but I'm going to show what it does. Update critical FOT parameters, no. And verbose, it's also the default, it's yes. I think. No, it's not, but let's set it to yes. And then again, I use this add files, the files file that I have, and I put out the default. So the default is that it takes the coordinate image coordinate and a number and the highest number, and then it gives out as image magnitude and a number. Now it doesn't take, if you give it coordinate 5 file, for example, you don't get a magnitude 5. So the magnitude calculation works in the exact same manner as the find task. It gives you one file, number 1 file for running 1. If you run it again, you get a magnitude 2, and so on and so forth. Let's run it. We can just say execute. If you're using ordinary IRAF, you'll have to use, I actually can't remember, it's some command that you, I think it's colon, I think it's, let me just go in here and show you. I think it's, you should write, I think it's something like this, WQ. So when you're in also, let me just show you that you will get something like this on your screen, but it will be the entire screen and you can fiddle around with it. One of the very good things about IRAF, and one of the really bad things about IRAF, is that for some reason you cannot delete what you have written. So if you write something wrong, you need to say cancel and then write it again. In IRAF you can you can write something and then you can delete it again. That's a good thing. Alright, but in here we have the option to say save and quit. I'm not going to do that because I want to execute it, so I say execute. And then it asks me a couple of questions. So do I want to use centering algorithm centroid? Yes. Should the centering box be around 6 scale units? Yes. Should the sky fitting algorithm be mode? Yes. Should the inner radius of sky be 18? Yes. Should the width of the sky analysis be 5? Yes. Should the absolute radii, should that be 13? Yes. Should the standard deviation be 20? Yes. Minimum 42, maximum 30,000? Yes. And then we get a long list of photometry that we get. Alright, so what happened here? The thing is that I actually think it used it once for some strange reason. Or perhaps it did it for all of them. Let's take a look. I'm sorry, where are we? Ah, it's because radium 13. So I'm just going to check N13. I think I have magnitude 2 as well. Yeah. Let's say remove anything called mag 2. Why is that invalid syntax? Mag 2. Alright. Let's just... yeah, okay. I know why. There we go. Alright, so let's go to IC. And let's run it. ePath and run FOD. So we changed nothing here, we just run it. And yes, 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 yes. And as you can see, we get good photometry on almost all our stars, but not very many of them. So let me just show you what is the reason that I said that you actually don't need to exclude your files like this, your stars like this, but why it's a good idea. Just going to fiddle it with the microphone. Alright, so let's open one of the magnitude files and I'm going to show you what I'm talking about. So, as you can see, I have 3 stars in here. They have all good photometry, but if I haven't done what we did, removed, gave them names and removed them, I only give them names so I can distinguish them. I could call them something else, but it doesn't matter. But for some reason, I'm just going to check that, but I don't think it does it. You can see we have the ID here, but it doesn't take that with it. So we can see where we got it from. It's called Q1. That's not true, but it should be Q2. But nevertheless, so this is the file that we use. This is the coordinates. Name, X init, Y init, ID, the one chords. That's the file name. Chords file name. Not true. It's the one. I hope it is. Yeah, it should be. So as you can see, no, yeah, alright, so it's just because it numbers them down. Alright, but you have the photometry here, and it's all good. It's all good here. Observation time, you have that here, and so on and so forth. Now, let's open, let me just see the V, let's open that. What I would do then, and what I have done, as you can see, I have one of them that has bad pixels. All of this. I would simply remove it. It would reduce 1 star, but then again, I can't use that photometry for anything. So, what's the difference, right? Alright, so let me show you what I have done then. So what you do when you have done all of those things, you are basically let me get the checklist. There it is. You've basically done all of those things here, and now we're going to move the relevant files to the app.fot directory. So if I haven't done that already, I would have taken the magnitude files from in here and the magnitude files from in here, and then move into a new folder I call app.fot, where I have a lot of junk in here, but I have also added a new find stars. So what is that for? Let me show you. Let's close all here. Close all. Oh, there's no close all. Okay. And this is really the fastest way. Open. So let's go to AppFont and first open the Find Stars Pi. So this script is a little bit different. Not much, but a little bit. So what I've done here is I've just added some few things. So I still have standard stars and the standard star names, but then I've taken the image stars from this file here, which I call NGC up standard. So what I've done is that I've opened, let's just take for example, that's the last one I did it on. Let's just say I've taken oh yes, now I know what I'm missing. Let's just forget this. You can look at this and we're going to use it in a little bit. I just forgot something. Let's take a look at the checklist. Yes, we need to set up the catalog of standard stars. So this is where some of the magic happens. So we're going to say EPAR MKN ops file. But remember, there's also a MK ops file. That's not the task. You need MKN ops file as a task. So what do we have here? So we're just taking every magnitude file that we have. Doesn't matter. Then I've set up the files BVRI. That's the filters we have. The standard set. That's a file I've made, and it has wrong editor. It has a very specific setup. Some things that you really need to take care of, and some things that are not that important. So the name IC1613, because I know that the name of my standard star catalog calls it IC1613, and I know that my standard catalog, the Stetson catalog, called this one here M13. And then I put in the file names, not the coordinate or the magnitude files, just it should be the file name, the FITS file, the image that you got the photometry from. So in this case we have cal IC B1, V1, R2 and I1, because those are the ones that we used. And again here for M13 the same thing, B1, V1, R1 and I1. That's the thing. Then we need to set an output. I have selected standard ops file 1 because I don't want to override the one that I've done work on already. Then you should set the ops columns. I've set 2, 3, 4, 5, 6. You can probably do it 2, 3, 4, 5. The min mag error is 0.001. And that's it. I'm sorry, but I just forgot one very important thing. If you look at the image here, it's a still image that I've made and edited a little bit. You can see that there's a number here that is the tolerance. Here I have written 15. It basically tells how much space that IRAF, or in this case the ops file creator, should use to compare the stars. I've set it to 15 to be large, but you could probably get away with using 10 or something like that. I do believe that for, again, amateur astronomer equipment, that 5, which is the standard, it is, I think it's simply too little. But 15, 10 or 15, somewhere between that, should be okay. Alright, so let's continue with the rest of the video. And that's it. So you have two options here. I would recommend, for most cases, if you have a lot of observations, that you only output matched in all filters. Now the difference is significant. If you say no, you'll get a lot of images, you'll get a lot of observations, but most of them will probably not be in that many filters. If you really want to make sure that you have a really good fit, then say no, because then you fit the images filter by filter, not all at once. but in my case, I think when I run this, I get something like 16 and 13 images in each. Let's try to run it. So these are the things that you need to set up. This is the standard star set. You can call it whatever you want. It's this file here. What you need to be careful of is that between the name there should be a space, a colon, and a space. You can set many spaces after you want to do that. I have 2 spaces here, but you need at least 1 space between each. So if it looks like this, it will complain. Alright, let's try to, and obviously I've used asterisk to mark out that I want Joker, magnitude, Joker. So anything with magnitude in it basically will be run. Wrap, if you say no, you will get an output that is horrible to read for human eyes, but the computer couldn't care less. But I'll set it to yes, because then I can also use my little neat find stars py script. So let's run it and say execute. And of course we get an error, because I'm probably in the wrong. Yes. And now we are. Let's see, cd. I just need to do some cleaning up. IC16. Probably have both an F, delete F. No, it didn't create it. Alright, that's good. Alright, it didn't get that far. Oh, sorry. And let's just get to EPA mkns ops file again. Look at here. You put in the filters that you want, of course. I guess it says itself. We don't have the U filter, so I have only chosen B, V, R, and I. Again, standard set, you choose that for yourself. The standard ops file output, you'll get a 1 here, but you can basically call it whatever you want, or you could call it Pete or Cool Stars or whatever you want. And then let's try to run it again and hope that we. Yes. So as you can see, I get 14 stars from IC1613, which is why I think that when I've run the photometry on the other that we did before, I set the threshold lower, perhaps something like 15 or 20 or something like that, because we only got 4 stars, right? And now we have 14 stars in all filters, and we get N13 and 19 stars written to the observations file. Alright, now what I then did is that I opened this new. Now you get a, let me show you what you get. You get an F standard ops file. It tells you, basically it tells IRAF where the time is placed, in which column, the air mass, the X coordinate, the Y coordinate in filter B, the instrumental magnitude in filter B, and the magnitude error for B, V, R, and I. If you had U, U would be here as well. Alright. In the standard ops file, which is somewhere around here, let's just take the 1. You get IC1613.1. As you can see, even if I did, let me just open one of the magnitude files for perhaps something like this. You can see that it is 1, 2, 3. So the naming I did in the other catalogs, as you can see, is not transferred over here. The idea is only to get stars that I know are in my standard star catalog. There's no reason for me to do photometry on stars that I can't use anyway. Now it might be that when I run the photometry I get some errors, and then I have to exclude those as well. But for starters, it is completely ridiculous for me. Yeah, you can see I set the sigma to 20, so that's why. It is completely ridiculous for me to let me just see what I did it on M13. Just open the I1. Let's see what it is there. It's 50 or something. Perhaps I changed it because otherwise I would get no 20. All right, so I have no idea. I think it's because I perhaps I didn't save the settings correctly or something like that. It reverted to 50, but nevertheless I set it to 20. So yeah. Yes. So what it does is that it takes all of those for M13 or IC 13, 16, 13, and so on, and compares them to see, do we have, not photometry, because you can see I have some in-depths here, but do we have X center, Y center? Do we have a star in all 4 filters? Then it adds this one here. So if I didn't do that, I will get a lot of stars. But it will be probably some of them with perhaps only BV, some of them only with R, and so on and so forth. And because I get 14 and 19 stars in all those files, and I have looted out all of those, no, as you can see, I have some indexes here, and I want those. If you have, let's see, for example, this one, I would say if you have an observation, for example in M13, where for all 4 filters or 5 filters, if you have the U as well, you get in-depths as the magnitude, then remove them. There's no reason for you to have them there. But what you do then is that you remove all of those that you don't need, and then you take this part here for IC 13, 16, blah blah blah, and then you put that. I'm not going to do that, but I'm going to show you how I did it. So you put that in, I put it in a file I called up standard, like this. You can see it's basically the same, and then I remove all of those asterisks here because those are for the same star, so there's no reason for me to have them there. So I have all the way up to 14, as you can see. And then I do this. I take the NGCB standard, which is, as you know, again, the one we had before, we used for starters. It's just the same. And then I run it against the NGC62 up standard. This was for M13. Let's just open for, for IC16, 13. Let's just open that for this one. So it's the same. You can see it's the same idea. Got some in-depths and so on and so forth, but nevertheless, you compare them. And let me show you what you get. So we are in here, so we need to go one more and effort, and then we do the same command. Now what it does this time is that it tells me, because it's going to tell me exactly what I want to know, right? So I get M13 1, 2, 3, 4, 5, 6 all the way up to 19, which is what I have here. Then I go into my standard observations file, and then for the M13, let's go to M13. So you can see the 1, it's called 1541, so I'm going to do that. For the 2, I'm going to do, and so forth and so on. I'm not going to delete the asterisk in here, the extra part, because I'm going to use that, but I'm going to change all the names both for one of these and the other. I'm going to close that and say close without saving, and then I'm going to open the one that I worked on, just so you can see what it actually looks when I've done all the work. I think I've done it. So you can see I have S9, S75, F76, 84, 87, so on and so forth, and 13, 15, 41, as you can see, 623, 624, blah 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 and so on. But I removed some of them because some of them didn't have photometry in any of the filters, and why should I keep them then? Alright, so now we have, I hope you can follow me, otherwise you should be very welcome to ask questions, then I'll happily answer them if I can. Perhaps make, if it's sort of complex questions, I'll make another video sort of in more in-depth explanation for you. But let's continue. let's minimize this one. So now we have all we need to make the mkconfig file. So let's go back and say IPA mkconfig. Just make sure that I don't have a config file in here. I don't think so. Mkconfig IPA mkconfig. So you need the same thing, right? So the new configuration file, I'm going to call that standard config. I think it seems reasonable. My catalog is Stetson. If you use another catalog, you put it in here. The observation file, I can't call that standard obs file. My transformation equation, well, those are Stetson as well. I don't have a template. I don't need to change the cat deer. Verify, no. Edit, yes. And check, yes. So what it does is that it doesn't need to verify these entries here. I don't know what, but I want to edit the file. And then when I've edited and I'm happy and I'm going to delete it and all that, I'm going to say check to see am I an idiot or not. So let's do it. Let's run it. And it is running, and it is running, and we get an Emacs. Alright. So let's see what we got. So we got U. Well, we don't need U. So let's delete that. We need B, V, R, I. Don't change the numbers, because then IRAF cannot figure out where you put what. TB, TV, TR, TI, we don't need that. Color, and like I said before, I'm going to comment this out because I don't want to fit it. I'm going to delete the CU. I could also delete the CU here, but that's no. And the XU, because again, I'm not going to use. Oh, sorry. I'm not going to use the U filter. And also I'm going to delete this one. So now I have told IRAF that when I do run this fit params, I want to say, well, I want to fit these parameters over here for my standard catalog with errors and all that, and then I'm going to compare it with this on these equations here. So I'm going to fit for B, V, R, and I. So yeah, let's close it and see whether I'm a fool or not. So let's see, XC, sorry, yes, it should save it. And we got catalog input variables 8, first catalog column 4, last catalog column 11, observational input variables 24, first observation column 3, 24. That's not interesting. What is interesting is we got no warnings and we got no errors. So we are completely ready to run fit params. Now I must warn you that when I've run photometry on I think I have a part test one, so I'm going to go to part test 2. When I have photometry from a telescope like the one I've used here, I'm fairly certain that I might get some big errors. It's not professional telescope, right? And it's not professional filters. It's amateur equipment. But I do think that I will get a reasonable photometry. Let's try it out. So I've changed some numbers here. So I changed the fit convergence tolerance to 7 to the minus 10 to the minus 5, because I know that I should up the tolerance a little bit for my for these kind of I've run it before and I got that. The maxed iterations, I have 20. I think that it is standard that it's 15. It's not enough. N reject, I have set that to 5. Low reject, high reject, I haven't changed that. Grow, not changed that. Interactive, yes, let's do that. Log on match, yes. Log fit, log results, yes. Let's do it all. Now we're ready. Let's try to do it. So let's see. this is the super nice window. Let's see what we got. Alright, so let's see. So this is the residuals and this is the function. So as you can see, we've got 7, 5, 18, 5. This is the magnitude. And I must say actually that an RMS of 0.5, that's not too bad. And it got it after 5 iterations, so the max iterations is not that, yeah, it's actually pretty good. So I'm happy. Let's say Q. Yes, I do. Oh crap. We didn't get a, alright. We didn't get an output, so let's just say fit out /1. And we didn't get fit, no. So yeah, let's try to run it again and hopefully it does it a little better this time. So let's make it bigger. But you can see the solution converge, and that's really what you should care about. Let's try again. Yes, I want to save it. Yes, next. Solution converge, an RMS of 0.606. That's not 17 iterations. So we can see if I set it to 15 iterations, the solution would not have converged. But an RMS for this kind of observations is deleted 4 points, but we got 27. That's pretty good. Rejected, low reject and high reject, we got 27 and deleted 4. That's pretty okay. I think that's enough for a good fit. And we could probably try to solve for the I will probably do that for myself and then perhaps post the result, but we could probably perhaps have solved for the extinction as well. But if we get a number that is very much different from the one that we have, the standard numbers, then it's not a good idea. I think we should try to do it. Should you do it? Yes, we should. So what you can do if you're in here and you are not particularly happy about what you got, you could say, well, I have said fit, and then it's EXV, and let's just set it to 0.1 like that, and then we say F for fit, and then we say I think it's V show. So let's take a look. So the extinction is minus 0.35, which is not so good, I think. So what we need to do then is to do a little work. Let's say standard ops file. Let's open the config, because I can't remember the numbers. mkn config, where are you? mkn, no, it's the std. There it was. So let's see what the number is. The standard number. It's for B. For V, let me see. Yeah, V. It is 0.160. And what is the RMS? It's 0.4761. Let's just say const exv. Just see what it is. It was 0.160. No. Now, if you're pretty sure that your parameters are okay, you can just say fit params. It will run it and it's a list. Yes, that's on. Yes, standard config. Yes, it's out one. Yes. All right. So let's try to look at this here. So here we have 0.5. Now let's just say vshow. Now we get the values here, so we can see the XP is 0.309. So let's say fit exp. Let's set it to 0.309. Fit it. And now we get, I think, a little smaller RMS. The RMS here was 0.59 and here is 0.443. Let's say vshow and see what the value is. Minus 0.23, and pretty large error, right? So I'm probably not going to trust that value. Let's go up again and let's say const exp 0.309 fit. We're going to get a little higher error, but we do get a better value. And then we get the 0 point as 5. This is the 0 point difference, right? And we got a color correction here. You can say they're pretty big errors, so that's not so good, but nevertheless. So we're going to say quit. Yes, I do want to save the results. Alright, it's fit params. Yes. Alright, let's just make it bigger so you can see what it says. So apart from all of these little errors that we had, what you need to look at is whether your solution has converged, and what the RMS is. If it's incredibly huge, and compared to a professional telescope with very good photometry, where you will probably get something like 0.03 or something like that, this is not too bad actually. So let's just say Q, yes I do, yes. Solution converged, Q, yes, solution converged, yes, solution converged, yes. Alright, so at our, what did I call it, fits out one. So this is what we have. So we have solution converged. Let's just see, we have a lot of B fits. I'm going to take the because it simply just appends it on it. So we're going to delete this one here. So BVRI. Let's just check we only have BVRI. Okay. So you can see status 0, solution converged. Variance, you can see the chi-square 0.94. The reduced chi-square, which is this, should be somewhere around 1. It's not that good, but it's okay. And it put the weights on the photometric, and we got some derivatives, values, and errors. So these are the ones that we're going to use in invert fit, or what was the other? No, not that. Checklist. Transform the magnitudes using eval fit or invert fit. Alright. So as far as I remember it, we only need this file here, but I'm not that sure. But here we have the values that we want. So you can see pretty high errors. What you can do is that you can use the 0 point here. I think you should, can't remember if you subtract it or add it to, I think you should add it to, because it's a 0 point offset. I'm pretty sure you should add it to, let me just show you. EPAR FOT. Let's see, FOT pass. So you can see you have the 0 point magnitude to 22 here, right? No, that's AppFOT. Yeah, cancel. DeoFOT. And then, but Nevertheless, you can just go into your one of your magnitude files. Let's just take this one, and you should have the 0 point ready available somewhere around here. Sigma gain EP 0.0.0.0. Z magnitude there, 25. So that's the 0 point. So in this case, you would, and this is the same for all the fits here. So this is just a number that you choose, and then in this fit parameter, I'm just going to save that. Sorry, I'm just going to save it. For example, here you would just add this is the B, so we have 5 here. You would add 5, so the 0 point is something like, no, that I think maybe you should subtract it. I have to look that up and get back to you. But nevertheless, this 0 point that you get here is an offset from this 0 point here, and an offset of 0 point of 20. That's probably not that off. Yeah, I think, yeah, 19, something like that. I think that's okay. All right. I'm just going to check something, but because I'm not absolutely sure. We can close these because we don't need them anymore. Let's just take EPAR invert fit. So you need a list of observations file. That's transformation observations. You need test out and part test 2. Yeah, that's what I used.